Today we're on page 5 of our Chapter 13 notes packet, solving trig equations. So we're going to continue to solve trig equations, quadratic trig equations, but these are not factorable, all right? So if something is not factorable, then what do we use? The quadratic formula. You can always use the quadratic formula on any quadratic trig equation. But for the ones that are not factorable, then we are forced to use it. We're going to round the two results of the quadratic formula to 4 decimal places. And remember, in the end, you must find the angles. Don't just stop when you solved for the trig function. Okay, so first, let's look at a quadratic equation that's not a trig equation, all right? We want to solve for x to 4 decimal places. So we have 3x squared minus 5x minus 4 equals 0. If we attempt to factor it, we would do 3 times negative 4 is negative 12, and there are no factors of negative 12 that add to negative 5. So we have to use the quadratic formula. Does everybody remember the quadratic formula? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so now off to the side, pull out our values for a, b, and c, and substitute into the formula. All right, so b is negative 5, and a is 3, goes after the 4, and after the 2, and c is negative 4. So negative 5 is positive 5, plus or minus the square root. That's going to be 25. The double negative here is going to be plus. 25 plus 12 times 4 is 48. All over 2 times 3 is 6. So I'm getting x equals 5 plus or minus the square root of 25 and 48 is 73. All over 6. Okay, so now I want 4 decimal places. So we have x equals 5 plus the square root of 73 divided by 6. I want that to 4 decimal places, and 5 minus the square root of 73 all over 6. So I go to the calculator. Alpha y equals, get my fraction. So 5 plus the square root of 73 divided by 6. 5 plus square root of 73 divided by 6. There it is. To 4 decimal places, 2.2573. So this is 2.2573. And 5 minus, I just, I can either go up and grab that and then just change the plus to minus. Negative 0.590, let's see, the 6, this first 6 is the 4th decimal place. So if I look to the right, 5 or greater is going to round out. So negative 0.5907. Negative 0.5907. Okay, so those are our 2 x values to 4 decimal places. Now, we want to solve a similar second degree quadratic trig equation, all right? So solve for all values of theta, theta greater than or equal to 0, less than 360, so degree measure, and we're going to round to nearest degree. We have here 3 cosine squared theta minus 5 cosine theta minus 4. Let me just move this over to here. 3 cosine squared theta minus 5 cosine theta minus 4 equals 0. Okay. Attempt to factor. Factors of negative 12 that add to negative 5. There aren't any, so we use the quadratic formula. So cosine theta, instead of x here, cosine theta is going to equal, a value is 3, b value is negative 5, c value is negative 4. Oh, well, this is simply the same as what we had above, right? So this is negative negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 times negative 4 all over 2 times 3. So cosine theta equals our 5 plus or minus the square root of 73 over 6. Okay, now what you're going to do, make sure please that you follow this step by step here. We're going to set up a chart, okay? We've got the two values from above, okay? Cosine theta is equal to 2.2573, and our other value is negative 0.5907. So once we go to our calculator and get our two decimal values, they go at the top of our chart. Next, we're going to find the reference angle. Okay, and how do we find the reference angle? Oh, go to the calculator and key in second cos, or cosine inverse of 2.2573. I hope you recognize that this will give us an error. Second cos 2.2573. Yep, it gives us an error. So we don't do anything more with that. There is no angle that has a cosine value of 2.2573. Here we key in cosine inverse of 0.5907, right? We do cosine inverse of 0.5907. Second cos, let me get out of that. Second cos, 0.5907. Miskeyed. Okay, it's the nearest degree, so 53.7, that's going to round up to 54 degrees. So our reference angle here is 54 degrees. Okay, now this cosine value is negative. What quadrant is cosine negative in? Quadrant, so using the all students take chemistry, cosine is negative in quadrants 2 and 3. In quadrant 2, a 54 degree reference angle would be equivalent to 180 minus 54, which is 126. And in quadrant 3, 180 plus 54 is 234. All right, so these are our two values for theta, 126 degrees and 234 degrees. Number 1, we want to solve for theta, theta greater than or equal to 0, less than 360 degrees to nearest degree. 4 cosine squared theta minus 2 cosine theta minus 3 equals 0. If I attempt to factor factors of negative 12 that add to negative 2, 6 and 4, and 6 and 2, not factorable. We use the formula. I don't have to write this, of course. Okay, so we're using the formula. It's in standard form. We'll pull out our A, B, and C values. A equals 4, B equals -2, C equals -3. So cosine of theta equals -2 plus or minus the square root of b squared -2 squared minus 4 times A is 4 and C is -3 all over 2 times A. So this is 2 plus or minus the square root of, that's 4. And then you can use the calculator for inside here. The double negative is going to be a plus. If you are using the calculator, please make sure you key it in exactly as it is without the square root symbol. Right? I would key in parentheses, let me get this right, parentheses -2, close parentheses squared, minus 4, you can use parentheses or times, minus 4 times 4 times -3. It's 52. All right, otherwise, if I continue by hand, that's 12 times 4 is going to be 48. And 48 and 4 is 52. So I have, leave myself room here, 2 plus or minus the square root of 52 all over 8. Okay, we're not going to worry about simplifying the radical. Rather now, take your calculator and get your two values for theta, meaning alpha y equals, I'm keying in 2 plus the square root of 52 all divided by 8, 2 plus the square root of 52 divided by 8, and that's rounding to 4 decimal places, 1.1514. So in my chart here, I'm going to say that cosine of theta equals 1.1514. And our other value for cosine of theta, I just grab that, go up and grab that, and change the addition to subtraction. So our other value is -0.6514. -0.6514. Okay, so these are our two decimal values to 4 decimal places. Now we get our reference angle. So we key in second cos of that decimal, second cos, 1.1514, error. Yeah, there is no angle that has a cosine value greater than 1 actually. So, and then the next one, again without the negative, because this is getting us our reference angle, so I'm keying in the cosine inverse of 0.6514. This gives us our reference angle. So second cos, 0.6514. The nearest degree, 49 degrees. This is 49 degrees. That's our reference angle. And the actual value of the cosine of our angle was this negative value. So cosine is negative in what quadrants? Quadrants 2 and 3. All right, so quadrant 2, we're looking at 180 minus 49 for an angle of 131 degrees. And in quadrant 3, an angle of 180 plus 49 for 229 degrees. And there's our two values, 131 and 229. And if you want, you can pause the video and try number 2 on your own. Are there factors? If I was to attempt to factor this, are the factors of -4 that add to -1? No, it's not factorable, so we use the formula. So tangent theta, we're solving for tangent theta. That's going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And a is 2, b is negative 1, and c is negative 2. So a is 2, and b is negative 1, and c is negative 2. So tangent theta equals double negatives, that's going to be 1 plus or minus the square root of 1. Again, there's a double negative there, so that's going to be plus 16 all over 4. So I have 1 plus or minus the square root of 17 all over 4. Now, so tangent theta equals go to the calculator, key in 1 plus the square root of 17 divided by 4, rounding to 4 decimal places, 1.2808, 1.2808, and then just go up and grab that and change the plus to minus. Negative 0.7808. Negative 0.7808. Now for a reference angle, right? Second tan, 1.2808, 52 degrees. And for the 0.7808, second tan, 0.7808, 38 degrees. These are reference angles. Okay. Now, this decimal value is positive. What quadrants is tangent positive in? It's positive in quadrant 1 and quadrant 3. So the reference angle of 52 would be its own angle in quadrant 1. And in quadrant 3, we would take 180 plus the 52 to give us an angle of 232 in quadrant 3. So here's two values. And now a reference angle of 38 degrees. This decimal value is a negative value. What quadrants is tangent negative in? Quadrant 2 and quadrant 4. So a reference angle of 38 in quadrant 2 would be equivalent to 180 minus 38 degrees, which is 142. And quadrant 4, 360 minus 38, 322. And there we have our 4 values for theta. Next, if you want to pause the video and try on your own, the question on the top of page 6 of the notes. All right. Now coming back, let's put this in standard form first. So 5 secant squared theta minus 4 secant theta minus 2 equals 0. If I attempt to factor, 5 times negative 2 is negative 10. There are no factors of negative 10 that add to negative 4. So quadratic formula. A is 5, B is negative 4, and C is negative 2. So here secant theta equals negative b, negative 4, plus or minus the square root of negative 4 squared minus 4 times 5 times negative 2 all over 2 times 5. Double negative is going to be positive 4 plus or minus the square root of That's 16 plus, because there's a double negative there. Again, you can use the calculator. 20 times 2 is 40. All over 10. So it looks like we have here 56. So 4 plus or minus the square root of 56 all over 10. Now, this is secant theta, okay? Secant is equivalent to the reciprocal of what? The reciprocal of cosine. So let's just take the reciprocal of our fraction here. So we'll say that cosine theta equals the reciprocal, 10 over 4 plus or minus the square root of 56. And now we'll make our chart and say that cosine theta equals let's go to the calculator and let's key in 10 divided by 4 plus the square root of 56. That decimal to 4 decimal places, 0.8708. And for minus, negative 2.8708. Right. And hopefully you recognize that this is going to give us an error. All right, the reference angle for this decimal value, we key in cosine inverse of 0.8708 to the nearest degree. Um, 29 degrees. This is a positive decimal value. Cosine's positive in quadrants 1 and quadrant 4. So 29 degrees. And 360 minus 29 for quadrant 4 results in 331. And if I do cosine inverse of 2.8708, gives us the error. And this concludes our video for today. Thank you.